Okay, so today we're going to be talking about antiderivatives, and seeing as this is a fairly new section, I'm going to try and slow down the explanation so that hopefully by the end of this video everyone understands what an antiderivative is and how to take one. So this question says find the most general antiderivative of the function and then check your answer by differentiating. Okay, and the one that I've chosen is number 21, which says h of theta is equal to 2 sine theta minus secant squared theta. Okay, let's think about the trigonometric functions that are in h. So that'll be sine theta and also secant squared theta. Now suppose that these are the derivatives. Okay, now what I want to find is what would I have to take the derivative of, with respect to theta of course, to end up with these derivatives. Okay, so again, what would I have to take the derivative of to end up with sine and secant squared? And that something is going to be the antiderivative. So again, as I said before, suppose that this is a derivative, so that if I take the derivative of something, the something would be the antiderivative. Okay, cool. So we know that the derivative of cosine theta is going to be minus sine theta. But we don't want that. We want a positive sine theta. Okay, how would I do that? Let's try adding a minus sign to the front. So let's take the derivative of minus cosine theta. Now I would have to copy down the minus sign and then take the derivative of cosine, which is minus sine, as we said before. And then distributing, this would give me positive sine. Okay, so we know that this something is going to be minus cosine theta. And we also know that taking the derivative of tangent is going to give me secant squared theta. So once again, derivative, antiderivative, derivative, antiderivative. So all we're doing is treating h as if it is a derivative itself. Okay? And then we're finding the antiderivative, or the original function, you could say. So let's get into the solution. Well, I'm going to start off by saying, well, let f of theta be equal to the antiderivative of h. So basically what I'm going to solve for. And this d theta means with respect to theta. Okay. Well, we know what h is, so this is going to be the antiderivative of 2 sine theta minus secant squared theta with respect to theta. Okay. Now let's get into the actual antiderivative part, which we've basically already completed. Well, let's copy down the 2. Well, we know that the antiderivative of sine is minus cosine. So we can put the minus, I'm going to put it in front, and then we can write down cosine. And then minus. And we know that the antiderivative of secant is going to be tangent. So tangent theta. And this is the final answer. Is what I would have said if I forgot about the constant of integration. Now what is the constant of integration? Well, when you take the derivative of something, let's suppose that you take the derivative of f of x, which let's say f of x is 1. So that would mean that f prime is going to be 0. Now going backwards, you can't really guess that the antiderivative is going to be 1 from 0. Okay, so this plus c, or the constant of integration, means that, well, there could be a constant at the end after taking the antiderivative, and that constant could be anything. There's an infinite amount of possibilities that that constant could be, and we could know exactly what it is if they gave us a point for the antiderivative, but in this case they didn't. So this would be our final answer for number 21. Now they also told me to check my answer by differentiation. So I said, well, this function is f of theta, so while taking the derivative of f with respect to theta, now this derivative must give me h, this function. That's how I know it's correct. So if I take the derivative of this, well, the derivative of cosine is minus sine, so minus 2, and this is going to be minus sine theta, minus the derivative of tangent is going to be secant squared theta, and like I said, the derivative of a constant is just going to be 0. So this would simplify into 2 sine theta minus secant squared theta, and as you can see, the derivative of f matches up with h, and that's how we know that this answer is correct.